In this video, we will discuss about 2.5D rule and 4D rule, which is helpful in deciding the rejection of doubtful results. So, let's discuss the criteria for rejection of doubtful results. In replicate measurements, a situation encountered is that a few values in a set of values deviate significantly from the rest, and therefore there is a tendency to reject such values. This becomes a dilemma for the scientist to reject or to retain the doubtful value. Retaining such values will give rise to an error in the mean, while rejection may lead to discarding a rightful value. So let's discuss the steps for 2.5D rule and 4D rule. So the first step is discarding the doubtful or suspected value. Second step is to calculate mean using remaining good observations. Third step is calculate deviation from mean value and also calculate average deviation. Fourth step is find the deviation of suspected or discarded value from mean calculated in step 2. Up till here, all the 4 steps for 2.5D rule and 4D rule are same. Now, for 2.5D rule, if y value is less than 2.5 times average deviation, then suspected value is retained. If y value is greater than 2.5 times average deviation, then suspected value is rejected. And now for 4D rule, if y value is less than 4 times average deviation, then suspected value is retained. And if y value is greater than 4 times average deviations, then suspected value is rejected. However, a point to be borne in mind is that there is no statistical justification for the use of either the 2.5D or the 4D rule. Too often, valid data are rejected by use of these rules. Now, let us understand 2.5D rule with a suitable example. A student obtained the following results for redox titration of ferrous sulfate against potassium dichromate. The titer value are as follows. Find whether value 10.9 can be retained or rejected based on 2.5D rule. So, here's the solution. As per the question, the suspected value is 10.9. So, the remaining values are good results. We need to find out the mean of the good results, which comes about 10.35. Next is we need to find about deviation, which is a difference between good result and mean. That is, the difference between 10.5 and 10.35 is 0.15. Next is 10.2 and 10.35 is 0.15, and so on. Then we need to calculate mean of deviation, that is called as average deviation. And the last column is 2.5 times the average deviation, that is called as 2.5D. That is 2.5 multiplied by the value of average deviation, that is 0.1, which comes to 0.25. Now we will find the value of y, that is the difference between suspected value and mean of good results. That is, y is equals to 10.35 minus 10.9, which is equals to 0.55. So here the value of y is greater than 2.5D value. Therefore, the value 10.9 is rejected. Now we'll understand 4D rule with suitable example. A student obtained the following results for standardization of NaOH by using succinic acid as primary standard. The titer value are as follows. Find whether the values 10.7 can be retained or rejected based on 4D rule. So, here's the solution. As per the question, the suspected value is 10.7. So, the remaining values are considered as good results. Next is, we need to find out the mean of good results, which comes to 10.12. Next is, we need to find out the difference between good results and mean, that is deviation. The difference between 10.2 and 10.12 is 0.08. Next, the difference between 10.1 and 10.12 is 0.02 and so on. Next is, we need to find out the mean, that is average of deviation, that is called as average deviation, which comes to 0.183. Now the next column is applying 4D rule, that is we need to multiply 4 into 0.183, which is mean deviation, that is the value comes to 0.732. Now next is we need to calculate the value of y, which is difference between suspected value and mean of good results, which comes to 0.58. So here we can say that the value of y is less than 4D value. Therefore, the value 10.7 is retained